All right, here we have it. Last example for Unit 5. Okay, so just like the last one, we have two pieces, so we're going to have two separate tables that we're working with here. Sorry if I look tired. I'm a little sleepy. Oh, okay. So now this one is going to be a little bit different from our first one because we are going to have arrows. Because we don't have end and start points, we are going to have some arrows in a few directions here. This would be what I called a semi-restricted domain. So it will have some arrows. Okay, so starting off with our first table here, again, I'm going to mark this off. X, comma, Y. Color coding, always helpful because yay colors. Blue for this guy, X, and Y. So now our tables can't really be too big here because they don't have stop points. They just really have starting points. So what we're saying that we're going to be using our red equation when X is less than 0. So less than 0. So noticing right then and there that I have an open circle going on here. That open circle not included. So let's not write not included because we are going to include it in our table. So we're starting at 0 and we're working our way down. 0, -1, -2, -3, -4, -5, and so on. For our blue equation, we have when x is greater than or equal to 0, so 0, 1, 2, 3, 4, 5, 6, 7. Making note that this 0 point is going to have the open circle. But this 0 point will have the closed circle. All right, so going to my calculator here, this first one is super weird because all it is a 6. So if you weren't sure, you can still go to your calculator, plug it in, go to the table, and realize that no matter what value you have for x, the y value is always going to be 6. Maybe in your wonderful brains, it's jumping out to you that if I have the same y value over and over and over again, that's going to give me a straight horizontal line. That's the equation y equals 6. Remember that Voxhoy stuff from our last unit? Looking at my blue one, that's going to be a little bit different though because it has a variable in it. So 6 minus x, second graph. So we're starting at 0 and working our way up. So we're noticing a pattern of starting at 6 and going 5, 4, 3, 2, 1, 0. It's going down one unshine. So we said it was starting at 6. So 6, 5, 4, 3, 2, 1, 0, -1. All right, let's plot some points. So we have an open circle at 0 with a y value of 6. 1, 2, 3, 4, 5, 6. So we have an open circle there. -1, -2, -3. So as you can see, as we talked about, we're getting our straight line, which we can continue with the arrow. But the arrow is only going in one direction, and that would be this way, away from where the x's are getting bigger, because we only want this when x is less than 0. So we're going to the left with that arrow. And we can even draw an arrow down here to kind of show that. So now with my blue equation, I'm starting at 0, 6, which just so happens to be the same spot that I started at. So that closed circle is going to override the open circle. 1, 5, 2, 4, 3, 3. So this is just going down 1 each time. And again, that arrow for this one is going to be continuing on to where the x's are getting bigger because that's what the inequality says, not the other way. And so here, from example 1 to example 2 is what we like to call a continuous function. because they connect to each other. Here, this is a not continuous because I have to pick my pencil up to get to the next one. I can't just draw along on it. So there you go. Piecewise functions. Super duper duper important.